A library has A copies of one book, B copies each of two books, C copies of each of three books, and single copy of D books. Then the total number of ways in which these books can be arranged is, the first option is A plus B plus C plus D factorial divided by A factorial into B factorial into C factorial. Second option is A plus 2B plus 3C plus D factorial divided by A factorial into B factorial whole square into C factorial whole cube. And the third option is A plus 2B plus 3B plus D factorial divided by A factorial into B factorial into C factorial. And the last option is none of these. Well, the given books can be written here as A copies of the first book, that is A up to A times. The second copy is B1, which has B copies, B2, which has again B copies, because the second book consists of two volumes which have B copies each. The third set consists of three volumes each which has C books each, and the last has D books which has no repetition. Therefore, we have B copies of two books, say B1 and B2, C copies of three books, say C1, C2, C3, and the copies of D copies of D books which are different. Total number of books therefore become A plus 2B plus 3C plus D. Consequently, the number of arrangements will be A plus 2B plus 3C plus D factorial divided by A factorial into B factorial into B factorial into C factorial into C factorial into C factorial. That is A plus 2B plus 3C plus D factorial divided by A factorial into B factorial whole square into C factorial whole cube. Therefore, option B is correct. In a steamer, there are stalls for 12 animals, and there are cows, horses, calves, not less than 12 each, ready to be shipped. The total number of ways in which the shipment can be made is 3 raised to the power 12, 12 raised to the power 3, 12p3, 12c3. Since there are three animals, namely cows, horses and cows, each shell can be occupied by three of them. Therefore, choices for each stall is 3, and there are 12 stalls. Therefore, the required number is equal to, the required number of choices is equal to 3 into 3 into 3 12 times, which is equal to 3 raised to the power 12. If 8 persons are to address a meeting, the number of ways in which a specified speaker is to speak before another specified speaker is, first option 2520, second option 20,160, third option 40,320, and D, none of these. Let A and B be the two speakers, and if X is the number of permutations when A speaks before B, then by symmetry the number of permutations where B speaks before A is also equal to X. Therefore, 2X is equal to the total number of permutations, which is equal to 8 factorial. Therefore, X is equal to 1/2 of 8 factorial. That is equal to 1 by 2 times 4 40,320. That is 20,160. 160.